So in this video, we'll be taking up the homework on average rate of change. So I forgot to mention in the lesson, but I really didn't like the placement of this lesson with the first unit because it seems like we're throwing everything into the first unit. But average rate of change, you really don't have to reserve this conversation to polynomial functions. Just like even and odd functions, I didn't have to talk about polynomial functions in order to talk about even and odd functions. So I can talk about average rate of change for any function, whether it's a polynomial function or any function that we learn later on in the course. So that's why for this homework sheet, I tossed in a function which was not a polynomial function. But you know what? I would say all the students, or 99% of students I teach, they're very good at average rate of change, okay? It's really just a slope calculation. So I gave you different functions and I asked you for the average rate of change from 2 to 6. So the first one, I really didn't even need a calculation because this is a line. So I knew the slope was 3. So the average rate of change must have been 3 because the rate of change is constant for a line. Okay, for B, it's a quadratic. For C, it's a cubic, no problem. For D, it's the function we'll learn in the next unit, which is a rational function. But no problem, just same idea. Find the slope of the secant line, right? And I forgot about E. E is an exponential function. It's not a polynomial, but no problem. Just plot the 2 points, or in graph the exponential function. Find the point when x equals 2 and when x equals 6. Connect the 2 dots with a line, and then you can find the slope of that secant, which is the average rate of change. Okay, so slope of secant, average rate of change. That's the big idea.